Okay, college algebra Monday, yes. So you're doing a real life problem, which is super easy, but that is so easy. So here, a can of soda. Okay, so the T of X is the temperature of the can, or the soda inside. And X is the minutes after it was placed in the cooler. So this is, let's find a pen. So find the temperature after 15 minutes. So all we need to do is, instead of X, put 15 and then find what it is. Those problems are super easy. Yeah, we just give it to you. But it is right there. Oh no, so X, that's what they're super easy, is the number of minutes. And they say find after 15 minutes. So all we need to do here, put 15 right there. And this is easier. Oh, wait. Why it looks so complicated? No, this is what it is. Find the initial what? This is what it is. Here it is right there. I don't know what they're talking about there, but here is how we solve it. Yeah. As the soda, its temperature in degrees is given by the following function. Oh, okay. Find the initial temperature. Oh, it says find the initial temperature. Two things we forgot. See, find the initial temperature. There are two questions. We didn't read it, so it's very important to read carefully. You want to find two things. Find the initial temperature and after 15 minutes. The same thing, because you need it when X equals 0, right? Yeah. This is what you do. Okay. The next clip will be, we'll continue. Next time we're supposed to do the test, but if you need an extra review next Monday, you can do another review. Or no. Okay. So everybody, so this is the review time. Next time we need to do the test. But if you need an extra review next Monday, I can answer questions. Okay. But I'm hoping you'll be done with the test by Monday night next week. Okay, now we're continuing. Okay, this was this problem. Now we're going to our review. And I think we should start backwards. Oh, these are the answers. We're going to start backwards from the logarithm questions. Okay, where are they? Okay, so logarithmic equations. We start backwards, but not too much backwards. So we still need to forward. Okay. Where we sang solve. Okay. So, oh, sorry. I'm sneezing. Okay, so use the properties. Okay, so we're starting from 31. Let's just solve some equations. Okay. So here, let's do 31. The only person here is Elizabeth, so she has to solve it. Whoa, so see if we can find X. Find the value of X is what it says. So what should we do? We can, so yeah, you need to find, so somehow we need to extract this X from the, so we can find this. Okay, so we can rewrite it as exponential equation instead of logarithmic one. Yes.
And then the positive 5 over making negative 5. And then separate.
Yes. That's correct. So do we have the calculator? So we're dividing by this. The test has 20 questions. They have a few of those equations to solve. But other than that, I think it's easy, 20 questions for hour and a half with one retake. It's pretty good. So from here, you just have to find the answer using calculator. See what Elizabeth would get. Yeah, 11.404. It's okay, it's close enough. Oh, paper cut. Oh, this is, oh yeah. It's got a paper cut under my toenail. It's the most ridiculous thing. Like, yeah, I just did this and it cut there. I was like, what the? I know, it's so amazing how paper cuts could be the worst thing. Yeah. Yeah, but you know, who would say paper would be so dangerous? Yeah, okay. Okay, so the next is 32. Let's do 32. Okay. What shall we do? We'll do similar things. Right? Because x is the logarithm, so we want to get it out. Well, write it as exponent. Right.
So we can separate it and be like h4 x divided by.
Wait. Just rewrite this as exponent, right? 4 to the power of 1 equals 3x minus 7.
Oh.
It's one of the simplest ways to do it. Is just write it as exponent.
Then you can use.
Yeah, then you just solve it for x. Okay. Got it. I'm not going to solve it, but you got it. The next one. Okay, the next one, we won't solve it. But, it's the same idea. Do you see 33? All we need to do minus plus the 4, and then it's the same as the previous one, right? Okay. So the next one is 34 is the same thing again. The only difference here, this is, let's do 34 because this is natural logarithm. So minus the 8. Oh. Minus 4. you want to have just to isolate just the logarithm, right? We could put the 5 in as exponent, but okay, let's just do it this way. Okay. So then we have logarithm of x equals minus 4 over 5. So now we just need to rewrite it as exponent. So how are we going to rewrite this as exponent? What is the base of this natural log? No, it's e. Remember, natural, that's why I want to do it, because it's ln. The base of ln is e. It's logarithm with base e, the Euler number. If it was log, then the base is 10. But ln is natural, n is for natural. Okay, so then since the base is e, to rewrite it, it's going to be e to the power of negative 4 over 5 equals x. So now we need to use your calculator to find this. Let's see if you can do it. 5. That's correct. 0.45. Good. Okay. Next one is 35. Okay, we're going to do 35. So what do you need to do? So you should move the logarithms on one side, right? And also we can use a trick if we want. I like tricks, but I think people don't like tricks. I'll just make the one into logarithm 5, 5. It's so much fun to do that. Yeah, and the reason, you know, you can make it, you can make one into whatever you want it to be. No, one is the ninja. It's the one. And I want it base 5, 5 because the other ones are 5. Okay, so then we're combining here the logarithms. X minus 8 times 4, this should equal log 5, 5. So now since the bases are the same, you can just take the insides, set them equal to each other. All right. And now we need to distribute, because we still need to find x. So this is going to turn into quadratic equation. It's going to be x squared minus 4x minus 8x plus 32 equals 5. Minus the 5, minus 12x, 27. I believe it's 27. All right, 32 minus 5. And it's good because 3 times 9 is 27 and 3 plus 9 is 12. So we can actually factor this. So it's going to be x minus 9 and minus 3. Right? You need to plug them both of them actually. With logarithms, you have to plug them in to make sure they don't give you a negative inside the logarithm. And if you plug in 9, it's good. They're both positive. But if you plug in 3, yeah, 3 would make both of them negative. So 3 is not a solution. Right. So 3 is not a solution. Okay. So this was problem 35. The next is 36 is the same, so we're not going to do 36. I don't remember if I uploaded the last class or not. If anybody wanted to watch the video, I need to check. Okay, so we're moving to 37. Oops. 37. Right here. Oh, make it big. 37. So now you can use a trick here. You can either use a trick or just use logarithm. You're using logarithm? Okay. Well, let's use logarithm then. What kind of logarithm? 10? Okay. Well, there are two ways to do it. Elizabeth chose to do logarithm. I'll write here logarithm. Using logarithm. She's using log base 10. This means she's taking log of both sides. She says log 32 equals log 16. When you do this, now the exponent can come in front using the properties of the logarithms. If you're going to get log of 16, so then divide by log of 16. It's a long thing. So then x equals 5 plus log 32 over log of 16. This was the long way, but you know, it just works. Now we're going to show Elizabeth the short way, and she might like it better. This is the, we call it the shortcut way. Okay. Did you get it? So let's show the shortcut. So the shortcut is, you kind of need to look at the numbers and see that this is 16, this is 32, but 32 can be also presented as 16 to the power, oh wait, not 16, but, oh wait. So let's see, we actually, yeah. 4 to the power of, let's see, to the power of what? Is it 4 or 2? 4 to the power of 2 is 16, no. So it needs to be 2 to the power of something. We need to get them down to 2. This is 2. Yeah, and 2 to the power of 5 is 32. So if you do this, the whole thing becomes 2 to the power of 5 equals 2 to the power of 4, the whole thing to the power of x minus 5, right? So then 2 to the 5 equals 2 to the 4 times x minus 5. And then multiply them. And then because the bases are the same, this means that 5 equals 4x minus 5. And then it's a little easier to solve. Minus 20. So is it 25 equals 4x? We could do this because 32 and 16, they're both some powers of 2. So this was a shortcut. Wow. So we're going to look at 38 and try to do similar shortcut now, even though we can do logarithms. No. Yeah, you see, because 2 and 64 is a base of, it's a power of 2. So since you know the trick already, we're going to present 64 as 2, 5, yeah, 6, one more. Okay, so then the whole thing would be 2, I'm just writing whatever is on the left, equals 2 to the power of 6 times 6x plus 4. So now, since the bases are the same, we can set them equal to each other and then solve the quadratic equation. Plus 8 would equal, we can multiply 36x plus 24. All right. So I'm not going to solve it from here. But what we need to do, move everything to the left and then solve the quadratic equation. All right. And then you're going to get your solutions. Okay, this was 38. Okay, next one would be 39. 39, we can do to the end and then we can take 5 minutes break. Okay. So 39, okay. Okay, what shall we do? 39. What do you think, Elizabeth? Now she's chewing. Okay, but you need to extract this y from the exponent. Yeah, to both sides. You're going to apply L1 to both sides. That's correct. So she's doing this. So this means that the 8y minus 8y would come in front, because the logarithm is the inverse of the inverse function of the exponent. So it's going to take the only the x, which is not an x, it's minus y, 8y here out. Yeah, so minus 8y, logarithm of e, which is 1, as she said. So this equals 1. Minus 8y equals logarithm of 6. You just need to calculate this. This was actually easy. This would be negative. 0.22. That's right. Okay, this was easy. I think this chapter is easy. Okay, the next one, what shall we do? Yeah, it doesn't need to be, in this case, doesn't matter natural or base 10. You can do natural, that doesn't matter. Yep, so it's going to be so the exponents came out in front. So then you need to put the x's on one side. So what we need to do, okay, so let's, I guess we can move everything on one. First, let's multiply out the first, the left-hand side. When you do this, we're going to get minus x minus 7. The reason we're doing this because we just want the x minus 8x. Okay, so now we need to combine the x's. So I'm going to move the 8 minus 8x to the left, and I'll move the number, which is just 7 logarithm of 11, to the other side. So we're going to have minus x logarithm of 11 plus 8x logarithm of 13 equals 7 natural log of 11. Again, the natural log is just a number. So now I'm going to factor out the x because I want the x. So we do x. So what's left is minus logarithm of 11 plus 8 logarithm of 13. And these are just numbers. Right. Let's underline it right here. See the x, so we factor out the x. So then divide by this number and calculate it. So the same thing here. Don't forget the minus. If it's easier for you to write it, you can write it as 8 logarithm of 13 minus 11. The order doesn't really matter. So don't forget the minus. This will be a long calculation, but you could probably make your life easier if you have the nice calculator and like use logarithm with base 11, let's say. So then you have one less logarithm. But 41. What did you got? They actually didn't calculate it, huh? They left it like 40. Oh, no, this is 40. Wait, they calculated it. What did you got? Yeah, this they got 0.926. Yeah, you got it. 0.926. 0.926.
Yeah, I was just trying to see numbers that you got rid of.
I didn't get rid of the negative. I just you can you can just rewrite it. You can write 8 logarithm 13 minus logarithm of 11. It's the same thing. Right? You can switch the order.
Oh, I see.
So it doesn't matter even if you write it the way it is. Oh yeah, I just got the x. I left the negative. Yeah, I just factor out the x without the negative. Okay. This was pretty good actually. The next one, let's see. Number 41 is the same thing. We're not going to do it, right? Oh, this time the only difference is, so look now here. The first one, they say round your answer to the nearest 1,000 and do not round the intermediate computations. For the next one, to look what it says. It says write the exact answer. So to write the exact answer, this means that you're not going to do the calculations because exact answer means without rounding. Oh, look, write the exact answer using either base 10 or base e. So whatever you're using, just your answer should look like, I'm just looking, if it's natural, 9 log 3 over logarithm 3 minus 8 logarithm of 7. Whatever it is, you need to leave it like that. Because this means exact answer. We're not going to give a digital, a numerical answer.
Okay.
Whew, the last one. Let's see. This is the Jesus type of problem. Oh, it's okay. So you need to substitute something because we're going to substitute this, right? So we got this u. So then the first one will be u squared. So once you do this, then let's do blue. Is going to be u squared plus 5u minus 14 equals 0. Okay. Does it factor? Oh, it does factor. Oh, how beautiful. Yes. Okay, so u is -7 and u is +2. So let's see what we're going to get. We're going back and substituting, right? So the first substitution would be -7 equals e to the power of x. The other one would be 2 equals e to the power of x. So now we need to solve it for x. Well, the first one actually cannot be solved, because if you think about it, e is a positive number, right? And x is just exponent, so there is no way you can get a negative number right here, right? Because 2.71, no matter what you put here for exponent, is never going to be a negative number. Because it's just exponent is just multiplying. You cannot make a number, positive number, negative by multiplying it somehow. Okay, by positive number. Okay, so then, or even a negative. I mean, you're not multiplying by negative, but exponent is just means multiplying. So then this one is not a solution, the first one. So the only solution is the only solution can come from the second one. So you still need to find the x. How are we going to find x? You need to extract the x, right? From the exponent, so it applied natural log to both sides, and our x comes in front, so we have natural log of 2 equals x natural log of e, which is 1. So x is log of 2. And it says round, so you're required to enter a numerical answer. So you need to use the calculator and get it. Okay. 0.69, it's correct. Okay, problem 22. Oh, this on the next page right here. Below is the graph. Okay, so translate this graph to become this other graph. So all we have is 1 point. So I'm assuming you need to go, you're going to be using this point right there. So let's just transform the point. So 1 and 0 is the point. So we're going to, for the x. So the x, this is the x, this is the y, right? So the x is going to, what's going to happen to this 1? Yeah, so if it says x -3, means we're actually going to add 3 instead of subtracting 3. So it's going to be 1 plus 3 is going to be 4. So x will become 4. Right? What's going to happen to the y? Oh, the only thing I see here is y is going to be 2 is going to be subtracted from y. It's going to be 0 minus 2. So y will become -2. So according to this, the point is going to be 4 and -2. So 1, 2, 3, 4 and -2. So it should go right here. So this point should go right here. And this is less, so it should be something like that. We're going to look at the answers. Try not to make more paper cuts on our bodies. Is it correct? Okay. These are not hard. They look hard, but they're not. So the next one, 23, graph. Oh. But what you need to do, I don't like graphing logarithmic functions because it's a little hard. You need to put values, but not too hard. You just need a few points. So let's, this one doesn't seem to be shifted left or right from the original much. So we can just get, make a little table. How many points does Alex want? Let's see. It doesn't say. 5. Okay, then. Does it say the asymptote? No. But we can figure out what the asymptote is. Okay, let's say Let's do 5 points x, y. So let's do -2, -1, 0, 1, and 2. Why not? Okay. So starting with the first one, so it's going to be 3 times logarithm with base 2 of -2. Huh. So this cannot be true then, because right now we are like, oh, we cannot have a negative. So this means that actually this one is not going to be in the negative side, on the negative side, right? Because the domain of the logarithmic function was the positives. How about the 0? Let's see about the 0. When this is 0, what would this be? 3 times logarithm with base 2 of 0. Well, what is that? It's infinity. So this actually we just found the asymptote though, right? Because 2 is negative infinity. Is it 2? I mean, to which exponent is the question? Equals 0. Well, 2 to the negative infinity would equal 0, kinda, right? Okay, this is the asymptote. The closer you get to zero, right? X equals 0 right here, the larger the value of the x will become. Because you need to be, it's 1 over 2 to the infinity will give you 0. So right, you need to have like bigger and bigger number here on the 2, and the bigger the denominator, the smaller the whole thing. So the asymptote would be this line right here. But we can find what the asymptote is. Let's just do this, okay? By just getting some more values. Okay, let's just get some more values in the positive. So we can do 1, 2, 3, and 4. Or to make your life easier, we can do 1, we can do 2, and we can do 4. How about 4? Let's make it red. This would make our calculations easier. So when x is 1, what would be the value of this thing? That's correct. So this is 0. Okay. When x is 2, what would be the value? You don't need the calculator. That's why I selected 2. Because, yeah, okay, because the whole thing is 1 times 3 is 3. Okay. So when x is 4, what would be the value of this? Okay, so when this is 4, the whole thing would be 6. Okay, so we got 3 points. Oops. So let's see. When x is 1, this is 0 here. What is 0? The y is 0, right? Okay. The y is 0. Okay. Then when x is 2, the y is 3. 1, 2, 3. When x is 4, this is 6. Well, looks a little. Oh, yeah, it's steep because it's multiplied, right? It's okay. So I think this whole thing. Now let's do one more. Let's do 8. When x is 8, this will be 3 times logarithm with base 2 of 8. So 9. Okay. So when this is 8, this is 9. Right here is 9, 8 right here. So it is a bit, but it's going to get closer and closer, but it's not going to go first in the negative axis. And then the closer you get to x is 0, the lower you're going to get here. Now you're getting closer to the vertical axis. So the vertical axis is the asymptote, right? Let's look at the graph. 23. This looks like that. Okay. So we needed to do to get a few points. Okay, the next one is 24. Well, let's see if we can figure out. 24 is like a puzzle. What do you think? That's correct. Okay, she wrote it down. 8. 8 times 9, that's correct. How about the next one? 4, that's correct. Go. You probably have to do this as 16 to the power 4. Okay, let's see how easy. This is the nice one. I use the properties of logarithm 25 to evaluate. Well, what would this be? Don't forget you need to put the 2 inside, you know, like the RV movie before you combine them. Two times 4, 2 times 2 is 4. No, 2 squared is 4. Is this 4, right? Yeah, look at that. So what will be the value of that? Yes. Yeah, this is just 1. Look how nice. Yeah. So the next one. To apply the rules for exponents. I mean, you can do it other way, but this is, I think, the way intended. 11 minus 7 is 4. So what would be the answer for B? Yes, yes. 4. Yeah, it is correct. It's 4. Okay. So the next one, 26. How nice. 26. So now we need to expand it. Okay, 26 is too easy. Let's just do 27. Okay. To expand it, you need to split it in single logarithms. Yes, each logarithm should involve only one variable. So start applying the rules. Oh. 27. Okay. So the first one, I would split it in. Yeah, you can split it. I'm just splitting. Yeah, first split the first 2 parts, and then we can split. Now the thing is, oh, which one? Now the square root now is for the whole thing, so it needs to be together like that. So the square root is just 1/2. So, okay, so I just write again logarithm. Yeah, but they go together. Oh, those. It's like that. Minus. I'll just keep this. So now take the exponents out. This exponent goes out, and this exponent goes out. Yeah. Yeah. So now we need to split this one right there. The first one now need to be split. So 1/2 stays, but then you're going to have logarithm y plus logarithm z to the 5th minus 3 logarithm of x. All right. And then the 5 would come out, and okay, the 5 would be in front. So then, since you wanted single logarithm, so 1/2 log y plus 5/2 log z minus 3 log x. Here we go. Number 27. Okay. So number 28 is the same thing, but just the 1/2 is for the whole thing. Now I need to combine them. I guess that's it. So we want to do one more. Should we do 28 or 29? And then we got back to where we started with. 29, you need to go back. Okay, so we need to go back. The exponents need to go inside. And then you have to combine them. Okay. So then combining. X5 on top. This on the bottom. We can put a square root there. And on top we have y6. That should be it. So this is for today. Everybody should do their test and the objective by the 15th, test by 16th. And on Monday the 16th, in a week, I'm going to, no, we can finish the review, or we can ask whatever questions we have, if you have questions. So we can show up or you don't have to show up. It's up to you.